Hi, in this video, I will be showing you problem number 9 of chapter 2, section 2. For the function f whose graph is shown, state the following. If an answer does not exist, enter does not exist, D and E. A. Limit is x approaching negative 7, f of x. B. Limit is x approaching negative 3, f of x. C. Limit is x approaching 0, f of x. D. Limit is x approaching 6 minus f of x. E. Limit is x approaching 6 plus f of x. F. The equations of the vertical asymptotes. So let's start one by one. Part A is asking limit is x approaching negative 7 f of x, which means we have to actually look at negative 7 and we have to allow x to approach negative 7 from either side of negative 7. So this is our x-axis, and 7 is here. So we have to approach negative 7 from either side of negative 7 along the x-axis and see what happens to the graph. So on the negative side of negative 7, the graph is having a branch here, and there is another branch over here to the right side of negative 7. But x is, if you look at the y, which is the function f of x, on the left side of negative 7, it's approaching negative infinity. On the right side of negative 7 too, it is approaching negative infinity. So the answer is negative infinity for the first part. Now the second part, limit is x approaching negative 3 f of x. So this is our negative 3. So we have to see on either side of negative 3 what happens to the graph. To the left of negative 3, the graph is approaching positive infinity. The right of negative 3 also the graph is approaching positive infinity. So the value of the limit is positive infinity. The third part, limit is x approaching 0 of f of x. So we have to look at the graph in the neighborhood of 0. To the left of 0, the graph is approaching positive infinity. To the right of 0, the graph is approaching positive infinity also. So it is equal to positive infinity. The limit is x approaching 6 minus f of x, which is part D. So which means you are going to allow x to approach 6 only from the left side of 6. So you look at the graph on the left side of 6 or through values smaller than 6. So we see this piece of the graph which is approaching negative infinity. Now part E, limit is x approaching 6 plus f of x, which means we have to allow x to approach 6 from the right side of 6. So you are going to look at the piece of the graph to the right of 6, which is this piece, which is approaching positive infinity. Now we have to write down the equations of the vertical asymptotes. Vertical asymptotes are vertical lines. Either the graph will approach plus infinity or negative infinity in the neighborhood of the number. So those are the vertical asymptotes. So in the neighborhood of negative 7, the graph is approaching negative infinity. So x equal to negative 7 is a vertical asymptote. Then x equal to negative 3 is a vertical asymptote, because in the neighborhood of negative 3, the graph is approaching positive infinity. Then in the neighborhood of 0, the graph is approaching positive infinity. In the neighborhood of 6, to the left of 6, it is approaching negative infinity. To the right of 6, it is approaching positive infinity. Either way, the graph is x equal to 6 would be a vertical asymptote, because the definition of vertical asymptote is that limit is x approaching the number, limit is x approaching a, either left side or right side, if f of x equal to infinity or negative infinity, then x equal to a will be a vertical asymptote. So x equal to 6 is a vertical asymptote, because to the left of 6, the graph is approaching negative infinity. To the right of 6, the graph is approaching positive infinity. So the equations of the vertical asymptotes are x equal to negative 7, x equal to negative 3, x equal to 0, and x equal to 6. Hope this video helps.